Swayam Prabha. Digital India. Educated India.
Now we discuss crevice corrosion. So, the crevice corrosion is a particular form of corrosion which is highly localized in nature, and of course, there is a galvanic effect that is associated with it because of change in concentration of reduction species or the species which gets reduced, and this happens in the crevice section of a particular metal or structural object which is under use. Let us say I have a bolt. When you use a bolt, it's basically, this is basically my bolt surface, the top part of the bolt. Okay, so let us say this is my bolt part. Now, only let us consider the half part of it. I will not consider the whole part, the half part let me draw. So, this is the crevice, a small opening where we have a solution or corrosive which is nothing but the electrolyte where corrosion is going on, and in this section is a small opening which is nothing but the crevice. We have stagnant condition. Though the outer part, rest of the part, let us say this is inside the solution, this entire stuff inside the solution, the rest of the part there could be turbulence or water or the flow in the corrosive, but this part, since it is a very small opening where the solution is going, solution is there already due to seepage and all those things, but here we do not have much of turbulence and it becomes stagnant. And that time in this zone there could be a possibility of a deep corrosion attack in the body, and that corrosion attack could be so violent that since this machine, if the system is under pressure or the tension, then there could be failure or fracture. So, the crevice corrosion always happens in the crevice part of a structure, and if I would like to define this crevice corrosion, the classical way to define is intense definition, intense localized corrosion frequently occurs within crevice and other shielded areas on metal surface exposed to corrosive. And this shielded area means we have a stagnant liquid there. So, this is the definition of crevice corrosion. And this type of corrosion, of course, we have already seen this type of corrosion is associated with the stagnant condition of the solution that is existing in the crevice. Now, what could cause crevice corrosion? The cause would be, one is, these are the causes. One is a narrow space between metal to metal, or metal or non-metal contact areas. Then we can have it, this crevice corrosion near crack, cracked part, or it can also happen, and it happens near in the C part, which is below the sea level, below the water level, that is due to accumulation of biofouling deposit that could lead to crevice corrosion, and there could be possibility of deposition of dirt, mud, or other deposits. So, let us say dirt in a water tank, this is water tank. If we have a small dirt which is falling and staying at the bottom, then we can create two crevices. This is one crevice, this is another crevice, where water can remain stagnant and it can lead to localized corrosion in this zone, and there could be a severe corrosion in this zone compared to the other surfaces of the mild steel tank. So, this is the definition of, this is the deposition of dirt effect, or it could be possible, let us say some bolt which has become loose and then fallen on the bottom of the tank. Now, you also see there is a crevice formation. So, this is also another crevice, so corrosion can happen here. So, all sort of deposits like this, they can cause crevice corrosion. So, now we have to see what are the factors that affect crevice corrosion. Before we go to the mechanism of crevice corrosion, the factors which are important in controlling the crevice corrosion or affecting, which can affect the crevice corrosion, let us just list those factors, and we can understand the importance of all those factors once we see the mechanism of crevice corrosion. The factors are, if we have, let us say this is my crevice, this is my crevice, this is one part, and this is basically crevice part. Now, factors, what are the factors? One is bulk solution composition, we will see that the initiation of crevice attack happens because of different oxygen concentration in the crevice and in the bulk of the solution. And of course, mass transport, which could be migration or diffusion or convection, and we will see that the mass transport, which is nothing but the chlorine ion transport in the crevice part in NaCl solution or the seawater solution, can lead to the autocatalytic nature of crevice attack. Third factor, we can have the change in crevice, change in solution nature, change in solution in the crevice. It means change in pH, change in chlorine minus ion concentration, all those factor, all those effect, all those issues can determine the crevice attack. Or it could be such that the stagnancy of solution. Now, fourth one is electrochemical reactions. Of course, what sort of electrochemical reactions are going on, that can affect the crevice corrosion. Then we have fifth, alloy composition. Effect of minor and major elements, and this alloy composition also decides whether the material or the alloy would go to passive state or it will remain in active state. And if it becomes passive, so the another factor is the quality of passivity or quality of passive layer, whether it is a very stable passive layer or it could be slightly or it could be unstable passive layer, those can affect your crevice corrosion. Then we have crevice type. Crevice type means whether it is a small gap or it is a crack, all those issues can lead to crevice type. These are falling under crevice type. Now, one major important issue with the crevice type is this gap should be such that it would allow the solution to seep in, but at the same time that means it should be wider enough to allow the solution to seep in, and at the same time it should be narrow enough to maintain the stagnancy. So, the two effect, one is wider enough to allow water entry or solution entry, and B, it should be narrow enough to maintain stagnancy. So, these two important parameters will be again seen when we discuss mechanism of crevice corrosion. Then we have the total geometry. Total geometry means whether in the area ratio total geometry, then another factor which is total geometry. It means that the ratio of this crevice area and the external area, then we can have the number of crevices, how many number of such crevices exist on this entire structure. So, those will definitely affect the crevice corrosion. So, now these are the factors which govern the crevice corrosion. Now, let us come to the mechanism of crevice corrosion. See, if we see the mechanism of crevice corrosion, then there are 4 steps in the mechanism of corrosion. First step is depletion of oxygen in crevice due to consumption at conversion in the Crevice region. In the Crevice region. And if we have depletion of oxygen in the Crevice region, definitely we will see that we are coming across a galvanic effect, as well as we have a area unfavorable area effect. This will come into this particular section. Second stage would be increase of acidity in the crevice, and this is happening because of hydrolysis. Third stage, if the system is passive metal, that case there could be possibility of passive layer breakdown, and this passive layer breakdown that is accelerated due to the increase in acidity in the crevice layer. And these two things can club the concept of can use the concept of Pourbaix diagram. Now, fourth one is the propagation of crevice corrosion with further hydrolysis, with added hydrolysis plus increase in acidity. So, these are the four different stages for crevice corrosion. We will now see in detail what are the reaction at different stages and how we have the increase in acidity as well as hydrolysis related phenomena, and then breaking down of passive film.